Good morning to all. I am Dr. Senthilkumar Rajagopal from the Department of Biotechnology, REVA University, India. So today I am going to talk about that anti-inflammatory effect of non-essential amino acid, that is a glycine. So it's a glycine. It's a very simple and abundant amino acid. It's very important for the gut health. So these are the structure of the glycine. This glycine is found in high amount in the human body, as it is one of the main component of the most abundant protein in the body, collagen. Collagen is considered a non-essential amino acid, so which is simply means that is so important liver can actually make it should be become necessary. So the liver can only produce the limited amount of glycine. The inflammation is the body first to respond to injury and infection. However, the inflammation should normally clear up very quickly after an injury, but only if glycine is found in high amount. So actually, the physiological concentration of glycine in a human body blood concentration is in 800 micromolar concentration. Even though it is not sufficient to, for example, the insulin secretion required that 800 micromolar concentration, more than that. So therefore, we are giving here endogenously the glycine to the in vitro study. So when you are glycine deficient, you can suffer inflammation from any tissue injury, even micro injuries such as what occurs all of the time in arteries. So therefore, we want to glycine is required for a proper inflammation response, and our modern diets are deficient in glycine. So the protective effect of glycine are unclear. So they are likely to multifactorial involving direct effect on dark cells, inhibition of glycine catalytic chloride channel, and inhibition of inflammatory cell activation. The protective effect of glycine was mediated, at least in part, by preservation of industrial glucose content. So here this slide shows the ethanol-induced signaling pathway. So here we want to know that PKC after ethanol induction, you can see the PKC can increase that causes the decrease in the activities SOD in the enzymic antioxidant and non-enzymic antioxidant reduced glucose that causes the inflammation. So therefore, we aim to present study was to investigate that anti-inflammatory effect of glycine, a non-essential amino acids in an in vitro model. So here we used that human umbilical vein endothelial cells for our study because endothelial cells can use for the lot of gene expression and this kind of inflammatory study. And we want to know that pro-inflammatory cytokine TNF alpha and interleukin. So here we use that inducing agent by alcohol 5%. And then we measure the myelovirus activity and enzymic and non-enzymic activity, and we use that RT-PCR for expression of the tumor necrosis factor alpha delta. So the results show that the expression of TNF alpha in the liver cells. So the TNF alpha expression was measured and recognized by RT-PCR method. So already I showed that the primer for the TNF alpha. So here we can see that endotoxin is significantly increased that pro-inflammatory cytokine TNF alpha, and ethanol also similar effect on the TNF alpha expression. So that this glycine reduces the ethanol induced cytokine levels. You can see that endotoxin lipobicytic can significantly increase that endotoxin level. Tumor necrosis factor alpha. Whereas alcohol also significantly increase the pro-inflammatory cytokines. Whereas the glycine supplementation significantly decrease the pro-inflammatory cytokine TNF alpha. And glycine can reduce the ethanol-induced inflammatory marker myeloperoxidase activity. So here we use that glycine as a 300 micromolar concentration and 24 hours study, and we use that 5% ethanol for 24 hours. And alcohol can significantly increase the myeloperoxidase and the inflammatory marker enzyme, whereas glycine supplement has significantly decreased the myeloperoxidase activity. And glycine can normalize the ethanol-induced enzymic condition superoxide dismutase. Here you can see alcohol can significantly decrease the superoxide dismutase activity, whereas glycine can significantly increase the superoxide dismutase activity. And glycine normalize the retinal-induced non-enzymatic reduced gluten activity. So here you can see glycine alcohol can significantly decrease the non-enzymatic activity gluten reduced gluten, whereas alcohol the glycine supplement is significantly increase the activity of non-enzymatic anti-activity and anti-activity. So here glycine suppress the retinal-induced nucleus factor gamma B level. So here you can see alcohol can significantly increase the nuclear factor gamma B level, whereas glycine supplementation significantly decrease the nuclear factor gamma B activity. So therefore, we concluded that chronic ethanol consumption causes the blood permeability. So this leads to the increasing level of the endotoxin lipopolysaccharide in the blood circulation. This after induction of lipopolysaccharide can induce the nuclear factor gamma P transcription factor level that causes the expression of nuclear treatment aggressive factor gamma, and it causes the inflammation. So the supplementation of glycine directly inhibit the activation of nuclear factor gamma B as well as the nuclear factor gamma P level. It causes inducing the activation and inflammation. Thank you. I'm ready to take the questions. If not, you can send the questions in my email ID, which I showed in my first slide. Thank you.